Hi everyone, my name is Darren Kosinski. I'm an R&D engineer on the FireMonkey team at Embarcadero. Today I'd like to show you some of the new things that we've added to the FireMonkey framework recently. We've had two major releases of Rad Studio since the last CodeRage conference. In those two releases, the changes to the FireMonkey framework have been in four major areas. We've added support for new runtime platforms. We've added a bunch of new components. We've implemented a whole bunch of platform services, a lot of them to support the new platforms and the new components. And we've made a whole bunch of performance improvements to the framework. So let's take a look at each of these in a little more detail. FireMonkey applications can now run on two new platforms. It can run on Android devices and iOS devices. Getting the framework to run on these new platforms means that we had to write implementations of the core FireMonkey platform services for both iOS and for Android. This is really how the framework is able to sit on top of the underlying operating system to do things like create application processes, create windows, receive events, draw on the display, and so forth. We also had to define and implement some new platform service interfaces for the unique features of iOS and Android. I'll talk a little bit more about the new platform services a little later in the session. We also had to create some new FireMonkey styles to allow the components to have the look and feel that users expect when they run an application on iOS or Android. By implementing the platform support by styles and platform services, it allows you to develop applications that run across all of these devices without having to use if-defs or platform-specific code. I should probably back up a little bit and explain what platform services are. Platform services are just interfaces, regular Delphi interfaces, that describe a discrete functionality that the framework or component needs from the underlying operating system. For example, the framework's T-application object needs a way to run the application, to wait for messages from the operating system, and then to dispatch those messages when they arrive. That functionality is encapsulated in an interface called IFMX application service. Similarly, forms need to have a way to create a window, show and hide the window, invalidate portions of the window display, translate coordinates between the window coordinates and the system coordinates, and so forth. And that's in an interface called IFMX Window Service. Animations and a bunch of other things make use of timers, and that's defined in a service called IFMX Timer Service. Alerts need to be able to show a message dialog, and that's in a framework called IFMX Dialog Service. Drawing needs to be able to access a canvas, and that's in IFMX Canvas Service. By defining the functionality in an interface, it allows both the framework and the application code to be platform independent. It lets most applications just work on both iOS and Android with a simple recompile. Let's take a look at some code to show you what I mean. This is the mobile controls demo that ships with Rad Studio XE5. It's a form. Here it's showing an Android form, and you see the target platform is set to Android. You can also specify iOS device or iOS simulator targets. In the designer, you can make it look like iPhone 5 or an Android device. What I really wanted to show is the code here. You see that there's no platform if-defs in here. This looks like any other FireMonkey form file. This one has a whole bunch of components, uses a tab control and a bunch of different buttons. Even here where we include the form resource, there's no if-defs around this. And as always, there's no if-defs in the form file itself. Even if we look at the main application, you see there's no if-defs in here. It's just what you'd expect, initializing the application, creating the form, and running the application. If we look inside the FireMonkey Forms unit, again, there's not a whole lot in the way of platform-specific if-defs in here. You will see a little bit of Windows if-defs in here. Most of that is for things that are required for the form designer. If we take a look at, for example, how you show a form, we look at here this method tCommonCustomForm, which is the base class for all FireMonkey forms. We look at the show method. We do a bunch of calculations for the positioning of the form and so forth. But then down here at the bottom, we call fWinService.showWindow. And fWinService, that's the implementation of ifmx Window service that I talked about earlier. That's the platform service. And here we're asking the platform service to show the window. If we look at where the platform services are implemented a little bit, that's in this unit, FMX platform. So here you see the T-Platform Services class. That's the actual registry for the platform services. And here you see IFMX application service that we talked about earlier. This is the contract that the framework needs from the operating system so that the framework can tell the application to run, can tell the application to terminate. It can have a means of handling or dispatching a message. It has a way to wait for messages. This is the contract that an application needs the operating system to fulfill. And if we look down at the bottom of this platform unit, we have this method that's called in the initialization section called register core platform services. So if we go into that, right now you see that the active platform is Android. So it took us to this unit, FMX platform Android. And here, register core platform services, you see this is where we register all of the platform services that that this platform supports. And this is where we have the implementations of those contracts. If you look in fmxplatform.ios or fmxplatform.mac or .windows, you'll see this same method, register core platform services. And if you look at the implementations, you'll see that the implementations of these services is wildly different between the platforms. But this is all at the very deep, most base level of the framework. From the standpoint of an application developer, none of this is relevant. All you know is that the framework needs to show a form, so you just show a form. And then the framework down in the very deep platform level, it knows how to interact with the operating system to do this. So that shows how it is that the FireMonkey framework works on these new iOS and Android platforms, is that we provided an implementation of the platform services, the core platform services, to run on these platforms. With some of the unique capabilities and features of iOS and Android devices, it made sense for us to introduce some new platform services. One of the key features of a platform service is that an application or a component can query to see whether the service is supported in the current runtime environment. So with the hardware features of mobile devices, by implementing these as a platform service, it lets a developer have some common code that runs even across desktop and mobile applications that can query to see if a platform service is supported. If it is, it can make use of them. If not, it can do other things. So these are some of the new platform services that we introduced in the last couple releases. The phone dialer service abstracts the functions that are needed to make and manage telephone calls. The notification center service defines the methods to publish a notification to the users, something that would appear in the notification center on iOS or Android. the share sheet service lets you access the platform's sharing features so that you can share text or photos through the social media services that are supported on the platform. The picker service, that provides an abstraction for the methods that are needed to implement the combo box or date time picker controls. On both iOS and Android, there's a very particular look and feel to these picker controls, and the native controls are very complex, using a lot of animations, and in a lot of ways they are very unique identifiers of the platform. And so we wanted to be able to make use of these native controls so that applications running on the device have a true native look and feel. So in order to do that, we made this picker service to abstract the functionality that we really needed. And the existing FireMonkey combo box controls and calendar edit controls that are rendered by FireMonkey itself on Windows and on Mac, those were converted to be implementations of this picker service on desktop platforms. But by abstracting this logic, it allows FireMonkey to use the true native controls on both iOS and Android. We have a web browser service that allows us to provide a T-web browser component. The service is currently implemented only for iOS and Android. We do know that there is a lot of interest in being able to use a web browser control on desktop platforms, but it's several orders of magnitude more complex to do this on the desktop than it is on mobile devices. Both iOS and Android have a nice encapsulation of a web view that makes it relatively simple to do this on mobile, and that kind of encapsulation does not really exist on the desktop. The last service, the application event service, that requires a little bit of explanation. So let's go into that in some more detail. The lifetime of an application on mobile devices is different from what we're used to on desktops. It's important to note that closing an application is not the same as terminating it, and the actual termination of the process is usually sudden and without an opportunity to close gracefully. It's much more like killing the process via the task manager. In fact, on iOS, that's exactly what it is. On mobile devices, what's important is to monitor transition events. When an application becomes active, that's when you want to check and create your database connections, restore the application state information that may be saved, start animations, things like that. When an application enters the background, that may be your last opportunity to gracefully clean up. When it goes into the background, that's when you should save state information, stop animations, close database connections. It's possible that your application may be reactivated at some point, or it may be killed by the OS. The enters background notification is really the last opportunity that you have as an application developer to do your cleanup. Both iOS and Android also notify applications when the operating system is running low on memory. When this notification is received, that's when your application should release any resources that are not in active use. Failure to do that means it's more likely that your application will just be terminated without an opportunity to do anything more. Let me show an example of how this service works. Okay, this is a simple application, just has a simple form. And what I've done is I've added an event to this form, an event called app event. And this function takes two parameters. One is a T application event, another is a context object, and it returns a Boolean true or false value. And what I've done is in the form create method, I've used this application event service. So I create a variable of the type IFMX application service. I have this if statement that queries whether the platform supports the service, whether it supports IFMX application service or not. And if so, it will place the instance of application service in this variable. And then I call the one method that's on this application service, which is set application event handler. And I set it to this method that I defined above, app event. So if we look at app event, you see that I just have a case statement here that shows different events that can be sent as a result of changes in the application state. These are the transition events that the operating system will notify you of. So finished launching, for example, that's an event that gets fired right after the application has launched. It's not necessarily on the screen at that point, but the application has launched. Became active. This is a key event. This is really where you want to start your animations, check to see if you have a saved state. If you did, you want to restore it at that point. Check your database connections, create them if necessary. This means that your application it has become active on the screen and ready to interact with the user. Will become inactive. This is an event that's sent by iOS. That's a warning that you're about to become inactive. There's a few different reasons for this. It could be that the user pressed the home button on the device. Another possible thing is that incoming telephone call came in, and so you get an interruption from the phone call. Entered background. This is a really important event because this may be the last event that your application receives. This will happen when the user presses the back button in your application or the home button. It's important to note that this is not a time to ask the user questions about whether they want to save changes or decide whether or not to close a form. It's important to know that your application is closing at this point. You don't have an option about that. You can't decide that you don't want to close yet. Your application is closing. Maybe it will be reactivated, maybe it won't. Once this event is received, you cannot assume that this instance of your application is ever going to receive any other notification. So in this event, this is where you want to save the state of your application, close your database connections, stop any animations. This is really kind of considered the shutdown event. Will become foreground. This is an event that can be fired just before your application is visible on the screen. Will terminate. This is an event that you really should not expect to ever receive. On older versions of iOS, they would fire this event before the application actually terminated the process, or before the OS terminated the process. On newer versions of iOS, they've pretty much done away with that. If the OS decides that it needs to kill your application or end your application, it just kills the process. It does not send this notification. So, and on Android, there's no guarantee that this will ever be called either. So, theoretically, this could be called, but it's not something that you should count on. A low memory notification. This is when the operating system needs to free up memory for some other process. Any resource that you don't have in active use, this is when you want to release it. And time change, that's an event that can be fired on iOS. It indicates that there was a significant change in time between the last time your application was active. Really, anything that you would do in here, you would probably also want to do in the became active method. But you could do things like recheck your database connections, and also if you have something that's dependent on the system time, you would want to re-get the system time at this point. But that's basically how you get notifications of these system events on iOS and Android. You use this application event service to set an application event handler, and then that event handler is what you would use to respond to these different things. In this little test case, I put this app event handler on the main form of the application. A lot of mobile applications may just have a single form, so that may be appropriate. If you have a more complex application, you may want to put this app event elsewhere. But that's how you monitor for events that come in from the operating system that indicate the transition of your application state. There's been another significant change to FireMonkey components as a result of adding support to mobile platforms. We've added support for multi-resolution images and styles. As devices have gained higher resolution screens, it's no longer possible to equate one pixel with one logical unit of size. Apple's Retina displays use 2 pixels for each logical unit of size. On Android devices, they use a variety of scale factors, sometimes 1 to 1, 1 1/3 to 1, 1 1/2 to 1, 2 to 1, even 3 pixels per logical unit. FireMonkey controls always specified their size in logical units. That way they're independent of the resolution. But for rendering styles and images, we need to have a way to choose a higher resolution image when the runtime has a higher resolution display. And so the way that we've done that is by introducing this multi-res bitmap property on TImage. And the screenshot that I'm showing here, this shows the a TImage component with a multi-res bitmap property. And the property editor for the multi-res bitmap lets you specify a different bitmap file or a different image file, not necessarily a BMP, but a different image file for each scale factor. So a scale of 1, that might be your normal resolution image. A scale of 2, that would be your Retina resolution image, for example. And then at runtime, the framework knows what the scale factor is for the device that you're running on, and it will pick the appropriate image to show at runtime. So now let's take a look at some of the performance improvements that have been made to the FireMonkey framework. A lot of this work has been driven by changes needed to get good performance on mobile devices, but pretty much all platforms can benefit from most of the optimizations. We found that the I/O system and memory managers of mobile devices is quite a bit slower than what we're used to on desktops. As a result, the logic for loading style resources has been rewritten so that it's now a lot more efficient. We've added a style cache to avoid having to reload styles from the file system. And we also create far fewer style objects than before. Overall, this makes FireMonkey applications much more efficient in their memory use. We also created an all-new canvas that makes even more use of the GPU, and we've created a new list component that's optimized for speed, and we've also moved some types around within the framework to reduce the memory use and allow for better smart linking. Let's go into a little more depth on some of these. First, the GPU canvas. Because device makers have put a lot of emphasis on gaming on mobile devices, on cell phones and tablets, the mobile devices tend to have relatively powerful GPUs compared to their CPU. We created a new GPU canvas that makes use of the GPU exclusively for rendering. This lets FireMonkey mobile applications have a high frame rate during operations like scrolling through lists and performing rotation animations. One thing about this GPU canvas is that it will not work with the older FireMonkey vector styles. It's been optimized to display bitmaps, so it has to use the new bitmap styles that we introduced along with iOS support in RadStudio XE4. This is the only canvas that we use for applications for iOS and for Android. There's not a software or CPU-based canvas available. We've done quite a bit of work on the listbox component over the past 2 releases. We added a lot of features to it to support things like grouping and section headers, things that you typically see on list boxes on mobile devices. We also did a lot of optimizations to the internal code. But despite this, we still found that it did not have adequate performance when it was trying to show a significant amount of data. So what we did is created a new lightweight list component that's called TListView. This is optimized for performance with larger lists, and it performs, or the optimization was largely achieved by reducing the use of styles. The ListView component itself is a styled control, but the items are not styled FireMonkey components. Instead, they're lightweight, non-styled item objects. This reduces the overhead of each ListView item and makes it much faster to render. It also has limited customization options. And it is supported on all platforms. It works on desktop as well as mobile devices. Let's take a look at the ListView component in a little more detail. So let's take a look at this ListView checklist project. This is one of the sample projects that ships with RadStudio XE5, and it shows the use of the ListView in a mobile application. So what we see here on the form, we have this ListView. It's populated using, we use live bindings to populate the data. The ListView has this item appearance object, and this item appearance object is how you set the properties to determine how each item will appear. This is the alternative to using styles. The item appearance object has a limited number of customization options, so it's much faster to load and to apply these properties to each item. And that's one of the things that gives the ListView a lot more speed than the list box control. Within the item appearance object, you have you can set header and footer properties, item properties, and properties that show up when an item is being edited. We also have this accessory property, and the accessory is for doing things like showing a glyph. The ListView component was intended to be used for things like a contact list, for example, where it may show a list of names, and then you may have you may want to show a glyph along the right hand side of the screen that would be a button to show more detail about a particular contact. And that glyph would be considered one of the accessories. In this particular test case or sample, the accessory that's used is a check mark. When you select an item, it would put a check mark here against the right side of the screen. And that check mark, where it appears, is determined by the alignment property. So here we have it set to trailing, which is why it would appear against the right edge of the screen. So these accessories is how you customize the appearance of the items. Let's take a look at the code a little bit. So here's the component on the form, the TListView component. And you see, as typical of a component, we have a TListView which descends from TCustomListView. If we take a look at that, we see that TCustomListView is a component. It descends from TStyled control, which means that the ListView as a whole does have styles that could be applied to it. But if we look at the list items themselves, which are declared in this unit FMX ListView types, this is what the items in the ListView, this is the base class for them. And you see it is not a component. It is not a styled object or a styled control. So the only way that the item can be customized is through the properties that we expose through the object inspector. So it has quite a bit of flexibility for being able to do things that you would typically see on a mobile device. Again, things like a contact list application, things along that line. But it does not have as much flexibility as you would with the full list box control, where each item can be styled. But the trade-off for that is you get much higher performance. We've also done some refactorings of the FireMonkey framework to improve performance. The biggest thing that we've done is we have made some changes to the organization of types within units. We've moved some types around to better enable smart linking. One of the key things is we made a better distinction between the 2D and the 3D logic, so that a 2D application no longer carries around as much of the logic that's needed for 3D rendering. And that helps the linker do a better job of removing the parts of the binary library that are not needed by your application. And overall, that helps to reduce the memory footprint of your application. And we also did some refactoring of the framework as a whole so that it correctly supports automatic reference counting, which is the memory model that is used for iOS and Android applications. That's something that we introduced in RadStudio XE4 when we added the iOS support. So that pretty much wraps up the presentation that I had for you today. Just to summarize, we've made quite a few changes to FireMonkey over the past couple releases of RadStudio. We've added support for running applications on iOS and Android using the same application code, really from the application level on up, and even for a lot of components. The same component code can work in most cases. We've added new platform services to enable support for a lot of the features of these mobile devices. We've introduced new multi-resolution bitmaps and styles. This especially helps on Android with its wide variety of resolutions. And we've made a lot of performance optimizations to the framework as a whole. And these performance improvements help with all platforms, both mobile and desktop. Thanks for watching this presentation, and enjoy the rest of CodeRage.
Joining me is Darren here in the studios. Thanks for joining us.
Sure.
So let's see, there are some questions here. It says, is this demo code available online at the moment?
I think all of the demos that I used in the presentation are from the demos that ship with XE5, and those are all available on SourceForge.
And there are new application events in iOS 7. Will those be added to XE5?
We're looking at the new events that are in iOS 7, and we will add the ones that need to be added. So I know that some, like for background fetch, things like that, those are probably likely ones that will be added.
Are there any restrictions that prevent GPU rendering in a thread?
No, not really.
If I still use XE2 FireMonkey, would that be implementable in XE5 for Android, or do I need to redesign the FMX file? Well, so I guess he's asking if you can migrate an XE2 FireMonkey to XE5 for Android.
Right. There would be a fair amount of work. A lot of the code would have to change. I'm presuming that this is a XE2 for iOS, which that used Free Pascal as the compiler for iOS. And the Free Pascal RTL and the Free Pascal dialect of Pascal is a bit different than what Delphi uses.
Would the FMX file, the form file, be similar?
Form file would be similar. That may transfer more easily than the actual code files.
different colors to list view items. Is there a way to apply different colors to list view items?
I believe you can set different colors on them. I don't know if you can set it on an item-by-item basis, but I think you can set some colors for the control as a whole.
Want to help the user see different types of items in the list. If the font and color are the same for all, it can be hard. Okay, I guess he's collaborating on that one. How does Arc behave on Android as long as GC is native for the platform?
Well, Arc behaves pretty much the same on Android and on iOS. It's something that's within the framework, within our applications and in our framework. The Delphi objects will be managed using automatic reference counting. The native device objects, things that exist within the Java runtime, those are handled by or managed by the Java memory manager and garbage collected. The actual native Linux code that's used, those are managed by the FireMonkey framework. So that's done through automatic reference counting.
Android, what about Android 3.x support in FireMonkey Mobile?
We support 3.x, that's the Honeycomb release, and most of the code works on Honeycomb. That's not a platform that we explicitly tested on, but most of the code, I think, should work on most Honeycomb devices.
Yeah, if the Honeycomb device has Neon support,
right?
Because there were some that didn't. But then, yeah, if it's the Honeycomb is like 0.1% or something like that of the market, so it's a very small share. So it's just something we didn't test on. Yeah,
most of the tablets ended up moving to the newer releases, the Ice Cream Sandwich or Jelly Bean. But generally, the code should work on a Honeycomb, but it wasn't something that we explicitly tested on.
Can you talk about big performance improvements?
The performance improvements mainly come in the area of a lot of the optimization that we did to get it to run on mobile devices. A lot of the components were optimized, the list box, the new list view, the GPU canvas, and also just throughout the entire framework, there were things that we found where the slower performance of the mobile devices really showed some performance bottlenecks. Wherever we found those, we did some optimization and cleanup of the code. That work is really spread throughout the framework. And then the other major change was moving around some of the units so that things can be smart linked better, and that helps keep down the application size. Probably one of the biggest things, too, was the style loading and implementing the style cache. That's probably one of the biggest improvements, and that applies to all platforms, not just the mobile one.
Okay. And there's some examples that show drawing with a stylus.
I don't think we have a sample that shows that.
But the stylus, if it shows up as like a pointing device, it's going to be like your finger.
Right, yeah.
It would be the same. It's just the way the user interacts with it is going to be different. But as far as from the platform's point of view, it should be very similar to touch or pointer.
Yeah.
Is there any tutorial on how to write FireMonkey components for all platforms? I think Ray has a paper on that, maybe?
I think so. I think we do have some tutorials that show how to write a component. Generally, when you write a component, as long as you stay away from platform-specific things or assuming that something exists on the platform, component should generally work fine. That was one of the main reasons for implementing the platform services, is that way in your component you can test whether the service is supported at runtime and then use that, whether that's true or false, your component can do the right thing.
Multi-res bitmap styles needed for GPU canvas sounds like a resource hog.
It can be. That's one of the reasons that we limited the number of resolutions that we have in the styles that we provide. For iOS, we basically have 2 resolutions, the standard and Retina. And for Android, we have 3 resolutions. We have 1, 1.5, and 2 times scale. So devices, we found generally were able to look pretty good with those 3 different sizes.
Are there features, or features FireMonkey are the same as Delphi or less than C++ Builder? So are the features the same in between C++ Builder and Delphi in FireMonkey?
Well, as far as the framework is concerned, they're the same. The difference really is that C++ Builder in XE5 only targets desktop platforms. So it targets Win32 and OS X platforms. So it does not target iOS and Android.
Do you have any idea not to use checkbox on ListView?
Well, something like the checkbox, that's one of the accessory views on the list view. When you are setting up the list view item, you can decide what accessory views you want, if any. There's not a need to have any accessory views on it. So it can be really just like a string list.
There's a question about supported device list for Android. There is the doc wiki. If you look for, I think it's platform features or platform requirements for FireMonkey runtime or FireMonkey framework or something like that.
Yeah.
So it has a list of devices we've tested on. If the device, the Tegra 4 processor the only ARM7 processor that doesn't have neon instructions, and then most everything beyond that should work.
Yeah.
How many sizes should I create images so as to look good on all devices?
Well, we found that 3 different scales worked well, having the original scale, 1.5 times scale, and 2 times. That's basically like the equivalent on iOS is the standard resolution, Retina resolution, and then one that falls right in between.
Well, what is the most beautiful thing about XE5 release in your opinion? What thing is settled already for the next release?
Probably the most beautiful thing is being able to take a single application, take a single piece of source code, and just change the platform you want it to run on, and see your same application running on an iPhone and on a Nexus or Android device, and seeing things work the same way, look platform appropriate, but really behave the same way. That's something that's really beautiful about the XE5 release.
Yeah, I remember when I recompiled my first iOS app on Android. I was like, oh my goodness, it just worked.
Yeah, exactly.
There are things you can do that will be specific to each platform, but yeah, it works, and that's pretty cool.
Yeah.
Is there a way to determine the size of screen and load different forms based on that? Any examples would be appreciated.
You can use the form factor property. That was something that we introduced in XE4. What that lets you do is create multiple forms with the same form family name, and there's some other parameters you can specify as far as the size of the form and the layout of the form. And what happens at runtime is if there are multiple form files that have the same form family name, the runtime looks at the parameters of the runtime device and tries to pick the form that matches the form factor the best. So that way, if you have a layout that you cannot handle with things like anchors and alignment, then you can create 2 separate form files or more than 2 form files, give them all the same form family name, and then the runtime will pick the one that most closely matches the runtime orientation and resolution.
Is there an FM example that comes close to the functionality of MS Paint that works on mobile?
Off the top of my head, I'm not sure. I know there's a lot of samples that we ship with XE5, and those are all on SourceForge. You can browse through those. There's both full examples, and there's what we call code snippets. And the code snippets are really, they're full applications, but they have more limited functionality. But
Good for seeing exactly what to do. Yeah, those are nice.
Yeah.
Any links to read up on differences with string handling in iOS and Android? Examples, zero-base strings and alternating characters within a string, etc.
Well, as far as the framework is concerned, if you're using Delphi code and the FireMonkey framework, the strings work the same. When you are running on a mobile platform, we do use zero-base strings, but you don't have to care whether you're running on iOS or Android. The runtime takes care of that difference. If you're going outside of the FireMonkey framework or the Delphi runtime and directly accessing something like a Java string object, an Objective-C, an S-string, then you have to handle those differences on your own. But if you stay within the Delphi framework and just use Delphi string types, the runtime takes care of handling all of that for you.
Have we considered converting the THTML viewer VCL component to FireMonkey?
Yes, we did consider that. There are multiple reasons why it just wasn't a good fit for coming into FireMonkey. For viewing HTML files, if you're on a mobile application, you can use the T-Web browser component.
Are we planning to support Tegra devices and Snapdragon with FireMonkey in the future?
Well, it does run on a number of Snapdragon
I
devices.
was going to say, I thought Snapdragon worked. That's what I have on mine.
Yeah, and some Tegras too. The important thing is that it has to be ARM v7 with Neon support.
Yeah, I think it was only one of the Tegras that didn't have Neon because it used some other thing. But
yeah, really, I think all of the chip makers have pretty much standardized on Neon support at this time.
how can I close an Android application? Is it application.mainform.close or mainActivity.finish or what? Which one is the correct way to do that?
You can use either one. If you absolutely want to make sure that the process is shut down, then really the only way to ensure that would be to call halt on the process. Mobile applications are not really intended to be shut down like that. A lot of that control really goes to the user, where the application just goes into the background, and it may get restored at some point, or the operating system may close it. But if there's a reason why your application absolutely must terminate the process, then calling the halt method in the RTL would be a way to do that. And that makes sure that all the finalization code gets executed and so forth. It may seem kind of abrupt, but it is actually a orderly shutdown.
So a question about NFC RFID sensor support in Android. I'm going to suggest they check out Brian Long's session. I'm not sure if he'll talk about that or not, but
yeah,
there's nothing that we block access to on the platform.
Right, yeah.
But there's some things we make really easy.
Right, yeah. We don't have a component for it, but some of the API should be readily accessible, so it should be possible to do something with that.
So if you do access that, you need to turn on the permission for that. How to display PDF file on iOS Android app? Can T-Web browser display it?
Yes, it can.
I don't think perhaps the halt will make it into the iOS App Store. Now you're saying that halt does shut down orderly, or that
it does. It does do an orderly shutdown. Again, the applications are really not intended on the mobile device to do that. The idea of closing an application is really not something that is designed to happen on a mobile application. Users use the application and they may move on to something else, but they come back to it. But the idea of closing and terminating an application, kind of a different way of thinking about things. That's not intended to be part of the application lifecycle.
And how can I make a list box do inertia with mouse like earlier version with mouse tracking property?
That would be probably a complex thing to do. We do have some inertial calculations that are in the FireMonkey framework that you can take a look at. That's how we do things like the scroll bouncing on iOS. We do a lot of calculations for that. So you can take a look at that, and probably take a look at what we've implemented in the list view and in the handling of mouse events in fmx.platform.ios. That would be a good example of how we use inertia services for doing calculations.
Okay, excellent. Thank you.